Welcome everyone. Good morning. Welcome to the last day of the Bioconductor conference. I'd like to introduce Marcel from the Bioconductor core group and hand over the word to him for his presentation of VisiumIO.
Thanks everyone for sticking around and bearing with the weather. I'd like to talk to you about this package that I've been working on called VisiumIO. So I'd say about like 3 months ago, I was given BiocIO, which is the base package that my package depends on, and BiocIO allows you to leverage the S4 software infrastructure that Daniel Van Twist worked on, among others. So what we do is we use the S4 to sort of identify files and read them in with an import function. So what I'm doing with VisiumIO is similar to that, but for 10X data sets. So if you want to take a look at the package, it is on Bioconductor devel right now, but the changes that I've made are still in development, so they're not pushed to Bioconductor devel yet. They will be very soon. And so this is the GitHub repo if you want to work with the latest version of the Bioconductor devel package. And then keep an eye out for any updates to the Bioconductor devel. So if you're using Bioconductor release, you might not see the changes that I've made so far, but so you have to switch over to Bioconductor devel. So I will give you an overview of the VisiumIO package. And I started with the 10X IO package, and that allows you to read in gene expression data from 10X. And I have a small table here that shows you what file extensions are supported. So a lot of the software that I've written for these package depend on the extension of the file to identify what type, and then subsequently read in based on the extension. So for H5 files, we have the 10X H5 class, and that will import a single cell experiment using the 10X matrix read-in function. And then you have a matrix market format, MTX format, and that will bring in a summarized experiment using the DGC matrix and their read-MM functionality. And then you have the, so in 10X, you might have some tarbals where they ship like the features, the barcodes and the expression matrix in one file. So that extension would be the tar-gz extension, and you can read that in using the 10X file list and then run an import command, and that will give you a single cell experiment. So there are many ways to work with the data. I try to make it as easy as possible for the user to import their data, so they don't have to like specify a lot of arguments. And then we also support peak annotation files, which are in tab separated values. So that's the 10X peaks constructor function. You get a gene ranges out of that, and the fragments file of the ragged experiment. So, but more recently, I've started supporting the Visium formats, and that's I created these classes for importing Visium data, including the Parquet file. I worked on the 10X spatial lists class that gives you a data frame list, and these are like implementation details, and I'll show you in a second how to import a data set from maybe a folder. That's usually I think that's typically what you get when you're running the pipelines, like the Cell Ranger and the Cell Ranger and Space Ranger pipelines. So mainly your input would be like a path to a folder. But so these are how things are working in the background. They're running a constructor function and generating a spatial experiment. In this case, using the VisiumIO infrastructure. So here's an example of how you would call the 10X Visium constructor function. You don't have to specify all of the arguments, but generally, if you downloaded the tarballs from the 10X website, you would specify the resources argument and the spatial resource argument. So you can see that those point to the tarballs, and then if you are working with the Space Ranger pipeline, then you would point to the code instead. So it's either the first two or the third argument that you're specifying. So I've added this Space Ranger out argument to make it easier to import all of the data at once. You don't have to say, this is my spatial data, this is my expression data. It just recognizes based on the classes and just gives you the spatial experiment as output. And here I'm borrowing from a lot of the work from Dario Righelli, who I'm using the import functions and sort of restructured the function to make use of the S4 system. So you have some options like low res, high res, and these are the images that come in the spatial folder, and then some other tissue positions inputs. So basically, you would probably just have to specify the Space Ranger out or the first two arguments. And I did add some examples in the package, so we'll go over those in a second. And so as an example for the Visium platform, usually your output looks like this. You have a outs folder, and then you have spatial folder with some images, a CSV file, and your matrix, either in H5 format or in matrix market format. So here's an example that we could run. So as you can see, I'm taking some of the example data from the spatial experiment package. And so I'm pulling that folder and saying Space Ranger out equals sample directory. And then the processing is either raw or filtered. And that refers to the like filter feature barcode folder or the raw barcode folders. And then you select what image you want to bring in for the spatial experiment object. So I can run those now. And first you have to load the package, of course. So as you can see, the output of this 10X this Visium class, it's kind of pretty crude, and I purposely left it like that because it shows you all of the other functions that are within the 10X Visium class. This is more of an intermediate step, but it's good to be able to see like what files are picked up in that folder and visible. So you can see that this 10X Visium inherits from the 10X file list, and it also has a spatial list component to it that has a 10X spatial list, so it knows how to import all of that data. So basically, we have the import function. Generally, when you're importing data, any of your arguments will be in that first constructor function that we just ran, like the 10X Visium function. And then you would just call import on that, and that would give you the data object back. So you can see that you don't have to do much. You just say import viz, and you get in this example, it's a 50 by 50 spatial experiment data object with some barcodes and some gene symbols. So this works for only a single sample, right? And you might have a folder where you have only one sample, but oftentimes you might have more than one sample. And that's where I worked on this 10X Visium list to allow you to import multiple samples at once. So I think the major inputs of these are just the sample folders arguments, and then a set of sample IDs. So again, I can show you the folder structure of what that looks like. So you have multiple outs folder and within the sample folder. So in this case, it's just called section 1 and section 2. You have spatial and your matrix folder. So we also have a set of folders, spatial experiment that contain more than one sample. I think in this example it's 2. And we can load that from our installed packages and look at the constructor function. So you say, this is my sample folder this is my folder that contains all the samples, and these are the sample IDs. So I used just the top level folder. And then you have to specify raw, because in the example, there's only raw barcode that folder that has well, I can show it to you in a second. Yeah, you can see that section 1 and the section 2 folder in this vector example directories. So once you've selected the type of image and the processing, then you can send it off to the constructor function. You get a small show method, which tells you there's a list of samples of, so there are 2 samples in this Visium list. So then you again, once again, you run import on the 10X Visium list, and you get a spatial experiment that, so essentially it first creates a spatial experiment for one folder and then another spatial experiment for the other, and then combines the 2 and gives you the full spatial experiment as output. So more recently, I've been working on the Visium HD platform. So the folder structure is a little bit different, but a similar way of importing all of the files. So you have your Visium HD top level folder. You might have a bin outputs folder, and then some folder that has a resolution. You can have more than one resolution. And I think typically you work with single resolution at a time, as far as I understand. And within that folder, you could have a filter feature barcode matrix folder with the matrix market format barcode, or you could have an H5 file and the raw feature barcode matrix folder. So you'd have to tell the constructor function that you want the filtered one or the raw one, and it will read in the spatial folder with that spatial list class. So here's what the constructor function would look like. So is everyone familiar with what a constructor function is? So the constructor function just allows you to generate a class. So Bioconductor has a lot of these constructor functions, like you may have used summarize experiment, right? It just allows you to create an instance of the class. So in this case, the input that we give it is the VisiumIO top level folder sample ID. We only have one sample, and may have multiple resolutions. So it will. I'll make some changes and allow you to select either one of the resolutions. I think these are micron, and by default it will pick the small 002 as the default. And then the tissue pattern has changed a little bit because now we're importing Parquet files. So here is a one of the example data sets that I've added to the package. So I put this in a Visium AC folder in ext data. So the Visium folder looks like this. So you can see on the bottom right, you have bin outputs, one resolution for the example, and a filter feature barcode matrix, the H5 file, and a spatial folder. So all of these I've reduced in size. Originally, the data was like close to 5 gigabytes, but I made it much smaller to include in the package. So once you point to that top level Visium HD folder, you don't really have to worry about what's inside of your folders. You just send it off to the constructor function. And here I'm using the native pipe and sending it off to import. So because this is a pretty small spatial experiment, the data is pretty small here. The spatial experiment doesn't take a long time to come up. But if you are working with a 5 gigabyte folder, then it will take, I'd say, like a little bit less than a minute, but you'd be able to get like a few million columns from that file. Here I'm using the mouse brain data set as an example. So you can see some of the stuff that's in the spatial experiment. You have call names, call data names. Like I've also added a resolution column that I can show you. So I'm going to save this to an object and say SE. So this is what the call data looks like. So you have a bunch of barcodes of coordinates, and I've added the resolution in the call data so that it's traceable and you'll know where from what folder data comes from. So I'm also working on supporting the H5 format right now. It works with matrix market format right off the bat, but because the folder structure is a little bit different. I have to adjust my code to that. But in the very near future, I'll have H5 available. So you'll be able to say like format equals H5 and you'll get the H5 data set within part of your spatial experiment object. Yeah. But
if you use that H5 format, will it also be read into memory or will it stay on disk and only be read?
no, it'll stay on disk. And then I'll use the Pérez function, the 10x matrix function that reads in H5 data. Then I'll build around that and return a spatial experiment question.
Yeah, so what you started on this, like, so and this question is because I'm not dealing with the HD stuff, but so the matrix itself of the counts is either an MTX or what's the parquet?
So the parquet is part of the call data. I think they say like the call data as a parquet file and
So basically the coordinates of each spot.
yeah.
And are you doing that in a lazy way as well as the HDF5 or you're just creating?
I don't know the internal details of the arrow, but I think I read it into memory. I'm not sure, but it's pretty.
You're using the arrow.
Yeah, I'm using the arrow package to read in the parquet. Yeah. But it just gives you back a data frame. So I guess it's in memory. It's a pretty good data.
Yeah, I think there's an option with arrow past data frame false realize it.
Yeah, but I'm not.
And it's
Yeah, yeah, it might not fit in a call data.
and maybe it's not necessary because it's just the coordinates.
Yeah. Yeah, because then I filter by all of the barcodes present in the data, so you get like a really long call data, but you don't use all of those rows.
So what's the typical size
Of the
HD?
you mean the parquet file or?
No, I mean like in terms of like how many of these beans are there?
Oh, for this one, I think there was like 3.5 million, something like that, column. Yeah. Yeah, I do have an RDS that we can load if you guys want to wait. But yeah, yeah, it's pretty big. So I'll show you the real world example, I guess. So this is the mouse brain data set. So when you get it from 10x, it's a tarball, but here I've untarred it and I'll show you the contents. So you have those 3 resolution folders. You have filtered, raw, spatial, right? H5. So I was working with this a little bit, so I untarred it and like changed the name, but essentially it's like 1.3 gigabytes for just for the matrix data. So you can see that it's quite big in size. So yeah, especially if you're loading it into memory. And I'll load the example spatial experiment object into memory. Should be in data, I think. Yeah.
You know, when you work with like single cell experiment, summarized experiments, using the various HDF5 matrix, you can use this like save HDF5 so you have save an HDF5 file.
Yeah.
Would that work?
That's a good question. You could ask the spatial experiment thing. Yeah, I think it should. Yeah, if you have an H5 backend, that would be the recommended function to use. But I can try it out and let you know.
But evaluate.
Yeah, so open an issue for that.
Oh, the HDF5 matrix. Well, I guess the package is called HDF5 array.
Yeah.
Okay. And there's a function to save, summarize the fragments that has a power matrix backed up by HDF5. Because basically it's saving an RDS file for the full data and
not links or there's many plans to make this work with one of us. Some of us support JSON, but facilitate fashion. Maybe some box.
I haven't looked at Alabaster. Yeah, I don't know if it works out of the box. I don't know what kind of format they're
It
using.
works. So, yes, maybe even one best experiment. So yes. Might be interesting.
Yeah, I think they prioritize like flat files. Is that right?
I think all data JSON, but
Okay.
can also
Right. I think the aim is to have like the language agnostic file format for that works both in R and Python. So yeah, might be. We could also like for things like this, you can write your own export method so that it saves it as a JSON, for example. There's this I had this idea of having like a projections kind of like slot to tell it, oh, I want to save it as a, or I want to load it as a single cell parameter or summarize parameter. So I haven't really fleshed that concept out in the code here because I know where I'm going, but that's also a possibility for like exploiting either JSON or things,
yeah, I'm just looking at the power busted space. Works out of the space. So yeah, once you have
Yeah. And then you can send it off to- Yeah. So this has the scary RDF has started is done loading. So let's see how big. So my memory right now is at 5 GB. GUI. So this has like 6.7 million column spatial experiment. So this is the actual if you were to download the mouse brain data set from 10X and run this function, you would get this kind of object. You have 6.7 million columns, 19,000 rows. So yeah, pretty big.
And you have the
Yeah. So I can do something like object size maybe. Whatever that number is in gigabytes. Yeah, like around 5 of this. Yeah.
Most processes.
I haven't looked at the matrix, so I just look the infrastructure code, but I don't really do the analysis. But yeah, we can take a peek at it and see.
This is the two.
Yeah,
So I don't know, I have a job that people this they said that the two microns is good. They recommend using the data. So these are not real resolutions. Like the actual. So these are 2 microns files. Then what they call the 8 micron resolution is a sum of like they create a megapixel. And like they recommend they say the 2 microns. Which is still pretty large. Well, I mean, I don't know. Like they say it's not as sparse, but
so I guess I should start with the 16 micron file.
I mean, that
as a
Genomics
default.
recommends 8.
8?
So
Okay, so I'll
maybe you should make
8 should be the default then. Yeah, so I just put the first 10, there's nothing in there.
So I mean, like, I know you're not looking for more things to do, but if you ever have time, I think for the originally, that put together this 10X Visium data package. But basically the collection of the publicly available data sets in the would be really useful to have a senior package for the HD, even with just one example, even with this one example that you already downloaded.
Yeah.
So that we can start kind of like basically you would just get out the private account or already.
Yeah, I guess I have to save it in several files. And I guess my export method would be conditional on whether it's using this PGC matrix or the 5 backend. Question, yeah.
I have a question to the in-memory EGC matrix. There is also this word sparse array package.
Yeah.
Is there a plan to maybe I don't know, or will this just stay with EGC?
Well, I don't know if sparse array used matrix market format. So, but I guess if there's a way to convert BGC to sparse array, it might be possible.